Hello students, I'm your study room educator and today we'll start new chapter number 15 called probability, which is the very last chapter of your maths ninth grade book. Now let us see the introduction to probability. Now in real life, you might have come into various situations and for example, you might have looked at the clouds and wondered that it will probably rain today because the cloud might seem dark or heavy to you. Or while writing a test, you might look at your friend who's not writing anything and you might think that I doubt that he will pass the test. Or you might look to the other person sitting next to you and he or she might be writing confidently with constantly without stopping, and you might think that most probably Kavita, if that is the person's name, so that most probably Kavita will stand first in the annual examination. Or maybe while watching the match with your friends or family, you might say that obviously it is 50-50 chance of India winning toss in today's match, right? So all these words, probability, doubt, most probably, chances, chance, all these show a level of that you're unsure about these events, that it may rain or it may not rain. You are not sure, but uh, according to seeing the situation, you're saying that it may rain today. So now let us see in what is written in this statement, that is the words probably, doubt, most probably, chances, etc. are statements that involve an element of uncertainty. As I already told you that an element of uncertainty here means that you're unsure whether whether these things that you're saying about that probably it will rain today, or maybe you doubt that the person will pass a test. That means that you're not sure about the thing, but you're confused, or maybe you can only predict that it may happen or it may not happen. Now, all these things have an element of uncertainty in them. Now, this uncertainty can be calculated or can be measured by means of probability, and it can be shown numerically. That is, you can actually see what is the percentage that a person might win or lose. For example, like in previous example, I told you about the cricket match, and you were able to say that 50-50 there's a chance of India winning the toss. Why how did we choose this 50-50? Because we know that half is the chance of India winning the lose. It will either win or lose. So there are only two cases here, right? So we just divided them into 50-50 out of 100, right? So for example, like you see here, whenever you toss a coin, there are only two chances, right? And that is how you are sure and you know that chances are 50-50. Now this is how you show probability, though probability only range from 0 to 1. So this is basically a percentage of probability. But if we take 0 to 1, then it will show us the fractional probability. That is, whenever we have 0 as a probability, the task is set to be example. For example, if I say that sun rises from the west, then that could never happen. So you'll say that it is impossible, or the probability is 0. Now, similarly, if I say that sun rises from the east, now we know that that is always going to happen. That sun will always going to rise from east, even if there is cloudy out there, because we know that even if it's cloudy, then it's only the sky is covered, right? But sun is rising behind the clouds, right? So we'll always say that it has probability of 1. That is, it is always possible. It is always going to happen. And similarly, here are other example about dye and other example of balls of given colors and all. And you'll learn about these in the next few slides. So let us move on to learn how to actually calculate probability. Now, before jumping on to the numerical and mathematical terms, let us first know how the probability actually came into existence. So let us see a brief, very brief history of probability. Now it was just now probability's history can be dated back to a year 1654. Now it was because of a French gambler, Chevalier de Mere. Now he was gambling at a station and he just stopped his game because he got confused with some problems with dice. That is by playing or by gambling, he was confused and he was stuck by the behavior of dice. That is how it behaves and all. So now he wrote down that problem and he approached a very well known mathematician of that time. That is 17th century mathematician because it was his time, right? So he reached out to the very well known mathematician and philosopher of that time, Blaise Pascal. Now he also looked at the problem and he studied these problems and discussed them. He sent it to his another peer, another very famous, very well-known mathematician of that time, Pierre de Fermat. And together they studied, and they explored about such problems, and they formulated into the probability theory. Now, this is how probability came into existence. That is just by a game of gambling. We made a very important discovery of a very important mathematical tool that helps a lot of fields in the future. Like now, I'll tell you why do we study probability, even if it was started with gambling, right? As we have seen that there was a French gambler who explored and who was curious about such the behavior of a die. Now, even if the probability started with gambling, it doesn't mean that it has to involve gambling, right? So probability is used in a lot of fields like physical sciences, commerce, biological sciences, medical sciences, weather forecasting, and numerous, I mean statistical mathematics, and you learn in higher physics. Probability is everywhere. Now in this course, in your ninth class course, you might say that probability seem easy, but as you'll go into higher classes, you'll see that probability will keep on accumulating, and it will be a very complex thing to handle, but it gives a very accurate, a very nice measure of how to visualize an event. So that is why it's very important to make your base clear. That is, let us make now that is, do not skip this chapter or by thinking that it is a very easy chapter, but make sure you make your base clear with this chapter. So now let us move on to the to an activity to help you understand how probability works. Now let us move on to our activity number 1. In this activity, you'll take a coin and toss it 10 times and note down your observation. That is, either a head will come whenever you toss a coin, you'll get either a head or a tail, right? So you toss that coin 10 times and record your observation. Now whenever now just record it like 1, 2, 3, 4, 5, 6. That is number of time. This was the number of times, and right here the number of times head have come. Or you can record it like this, or directly record it like 10, and you can have how many times head comes. Say we have 4 times head, and now out of now since 4 times head have come, so automatically the number of times tail will come would be 6, because 10 minus 4 would be 6. Now we have to write down the fraction of the number of times head will come up. So the fraction would be number of times head will come up would be 4 upon the total number of times the coin is tossed, that is 10. So we'll divide it by 10, and this would be our fraction, or we can reduce it to our form of 0.4, right? So this would be our this is our fraction of this. Now we'll do the similar thing with our tail also. So we'll just have the number of times tail have come up and the total number of times the coin is tossed. So we had 4, 6. These are just assumption. When you toss, you might get 3 heads, 3 tails, or you might 7 tails, or you might get 5 heads, 5 tails exactly, or whatever your value would be. So you'll do it accordingly, and the number of times tail will come up. So I'm writing 6 over here because I've assumed that 6 times my tail have come up, and 10. So it is 0.6. So we have taken out this fraction. Now, let us do this activity by increasing the number of times we have flipped the coin. That is, the same thing we have to repeat by tossing the coin 20 times and recording this our observation in the same way that we did above. That is, we have to record it with the two fraction that we calculated with heads and tails. And we have to take out the fraction here, right? So we'll repeat the repeat this activity again. First, we'll repeat it by 20. First, we have done it with 10 tosses. Then we have done it with 20 toss. Then we'll do it with 30 toss, right? So we'll keep on repeating the activity. Now we may stop at 30, or you may increase it to 50, whatever you want. And now, as you'll keep on doing it, you will realize that whenever you take out this fraction, for example, here we had 0.4, right? Now in here our heads will come out to be for example, let us say 0. I cannot actually take the number because I have not performed the activity, but I'm just showing you it may come out to be 0.48 or something, right? It may come out to be 0.6. Like for example, here our heads have come out to be this number of times, or you'll keep on doing it. Now, as you increase your tosses, for example, here 10, 20, 30, you'll find that the number of as the number of tosses gets larger, the value of both the fraction will come closer to 0.5, that is half, right? Because now you can see that how this 0.5 has come up. It may be said that it is 50-50 chance, right? Because how do you take out a percentage? By multiplying fraction into 100, so we get 50. Now that is how you get 50-50 chance, right? So as you increase the number of tosses, your data becomes much more much more exact, and you will get the fraction coming closer to 0.5. Now let us do activity number 2 with the coin. So here in this activity we have multiple groups of 2 students each. So we'll have for example, if your class has 30 students, so just divide your class into 2 groups, into many groups, that is 15 groups of 2 students, right? So now we'll assign each group a task of tossing a coin 50 times. And now they'll take out the observations like we did in the activity number 1. That is, we have to take out the number of times heads have come out and number of times tails have come out. Now remember that the coin should be of same denomination. That is, if you're using ₹1 coin, then it should be of ₹1, so that there is no change in weight or size of coin, right? So, and the answer will come out to be more uniform. So either use remember to use, if you're using ₹1 coin, then every group should be using ₹1 coin. So now we take out the now we record the observation regarding the heads and tails, and each group will add their observation in a table. Now I'll show you how to make the table. Now this is how the table is going to be. For example, our group 1, we have tossed 15 times. So our group 1 may have got heads 7 times and tails 8 times, right? So our number, so here we'll do. And now similarly, our group 2 will have, for example, it gets 5 heads, 10 tails. And now we'll keep on doing this. Now we'll add up the number of heads, we'll add up the number of tails, and it will be equal to the number of tosses that that all the groups combined have done. And we'll have in the bottom total number of times coin is tossed. That is, we'll add up the number of times each group have tossed, and we'll combine them all, and we'll write the huge number to be here. For example, in our case, we had 15 groups tossing 15 times. So we get our total number of tosses to be 15 into 15, that is our 225. So we'll write here 225. That is the total number of coin times the coin is tossed. And now on the numerator we will have cumulative number of heads. That is the total number of heads all the groups combined have got. So for example, we may take it to be 125, and this and similarly here we may have seen that all the groups combined have got tails to be 100, 125, 225. Now when we'll take out the fraction, we'll get a certain number. But now you'll see that as you keep on adding the groups. For example, here we have 15 groups, you may have 16, 17, 18, 30 groups. As you keep on adding the number of groups, so as you keep on adding the number of groups, your fractions will come closer to 0.5, right? So that is how we have done by activity number 1 and 2. We have examined how the probability of a coin is getting to be 1/2, and it will actually come in reality when we do it in infinite number of times. We will get exactly 0.5 as our answer. Now let us do the activity number 3. Now in this activity, we'll use a die over here, right? You would have seen a die, the one which we used to play snakes and ladder or maybe Ludo, right? It has numbers over here, 6 faces, as it is a cube, and cube has 6 faces that are equal in size, right? So now we'll use a die over here, and we'll throw this dice 20 times, and we'll note down the number of observed times these numbers 1, 2, 3, 4, 5, 6 will come up, because the outcomes of a die can only be 1, 2, 3, 4, 5, and 6, right? Because it has these numbers are written over here. Now we'll record our observation in the form of a table like this. So now number of times these scores have turned up, we'll write them over here, and we'll put up, and then we'll again take out this fraction similar to the ones we have taken out in our activity number 1 and activity number 2. That is, we'll take out the we'll have in the bottom the total number of times the die is thrown. So we'll always have the total in the bottom, and then we'll have each occurrence at the top. So the number of times 1 has come up, and similarly the number of times 2 has come up, 3 has come up, and we'll take out these fractions. For example, like we have written over here that number of times 1 has turned up, and total number of times the die is shown. For example, our 1 has come up 5 times, so I'll just write 5 over here. Now this will come out to be 0. It will be 1, it will be 4, so we'll have 0.25, right? Now and similarly we go on doing this. Now in this example also, since we have total faces 6 times, that is our total outcomes. Total outcomes are 6, because we can either get 1, 2, 3, 4, 5, or 6. We can get only these 6 outcomes. Here also, as you keep on increasing the number of throws with the dice, like here, as you keep on increasing the number of throws with the die, you'll see that the fraction of each face that is coming will come closer to 1/6, and that is equal to the to the number of times a face can come divided by the total number of the total number of faces the cube has. So now we can repeat the experiment. Like throwing a die a lot of times might be difficult because you have a lot of outcomes. That is, you have 6 outcomes. So you need a lot of need a lot of throws. So you can do the experiment in multiple of 2 groups, and or maybe again, like we have done in activity number 2, you might divide your class, and we have 2 people in each group, and so you'll get a lot of throws, and you will see that your fraction will come closer to 1/6. Now let us do our activity number 4. That is our last activity, and that is we'll use coins over here again, and the part of which is different is that we'll use 2 coins, right? So we'll toss 2 coins simultaneously 10 times and record our observation. But first, let me just write down that what our observation could be. So when we'll toss 2 coins 2 times, for example, let me name one coin to be coin A, let me name another coin to be coin B. So, for example, if I tossed it once, now what could be our outcome? That is, what could, when the coin will fell down, so what we might see. So, I might see that both of the coins have tails on their faces, right? So it might be tail, or I might see that coin A has tail but coin B has head, or it may be coin A has head, or coin B has tail, or it could be both of have them have heads. Can there be? Is there any other possibility that we can do over here? I There is none. So these are the only possible outcomes that could come. So we have total number of that is, we have total outcomes here to be 4. So now let us see what this table says is that number of times no heads have come up. So here no heads have come up, that is this case. So whenever this case will come, we'll add up 1 over here. And the other case is that number of times one head comes up. So whenever our one head will come over here, we'll add up to this part. That is, we have 2 cases. Now another block says that number of times 2 heads come up. That is our this case. So whenever this case will come up, we'll add 1 over here. Right? So now we'll again do the same procedure that we were doing in every activity, and that is we'll take out their fractions, that is total number of times 2 coins are tossed. So we have tossed in the question, in the activity is given, they are tossed 10 number of times. So we'll just write here 10, and the total number of times 2 coins are tossed, and the number of times no heads have come up, we'll write it over here, right? So it is number of times no head has come up. Similarly, we'll do repeat this procedure over here. And you'll see that as you keep on increasing your number of tosses, the numbers will come close to each other, and they'll come to be close to one exact value. That, for example, like we have seen in activity number in the die case, that the number were coming close to 1/6, and similarly in the toss, in the single coin toss case, the number were coming close to 1/2. Now similarly here, the number will come close to, this will come close to 1/4, this will come close, the number of times no head has come up. Actually, there's a little bit of mistake over here, that is the number of times one head will come up, which should be here, and here the number of times 2 heads have come up should be here. So now when we'll do this, so whenever our one head will come up, it will be 1/2, and whenever our 2 heads will come up, it will be 1/4. So your numbers, as you keep on increasing your number of observation, that is number of tosses, these fractions, that is ABC, will come closer to these fraction. A will come close to A and B, C will come close to 1 by 4 and B will come close to 1 by 2. Now, in this video, you have learned about, you have examined how probability works and how we calculate or how we calculate the fractions of an observation or an activity. And also you have learned about the words that how what numerically shows the uncertainty of our doubts, that is probability.